Welcome back to Physics with Ben. As you can see on the screen, we have covered so much on this topic: definition of heat energy, specific heat capacity, or heat or thermal capacity. We have looked at change of states, latent heat of fusion, latent heat of vaporization, specific latent heat of fusion, specific latent heat specific latent heat of vaporization. We are going to strictly look at calculations in today's video. You are welcome. Kindly subscribe and share this video. And so, as Ella said, these are the textbook I am using in today's calculations. Get yourself ready and let's keep the ball rolling. So let's start. Get your calculator set with you. Quickly, let's begin. Calculations in physics by Solomon Dauda Yakwa. My guy. I like this guy textbook seriously. I read question 20, question 48, page 221 of this book. Page 221 to page 222. Question 48, I read. A 90 watt immersion heater is used. Immersion heater is used to supply energy for 5 minutes. The energy supply is used to completely melt 180 gram of a solid at its melting point, neglecting energy losses to the surrounding. Calculate the specific latent heat of fusion of the solid. This is WIEC 1998. So, before I start these calculations, there is something I need to call your attention to. Anytime you come to my channel to watch a video, there is something I always tell you to make you get A's in physics. A good number of students are struggling to do calculations in physics. If you go through the way they mark and the way they answer questions, you will just laugh. So in this video, kindly follow me, and everything you see me doing, replicate it when you are writing any examination. For instance, I always emphasize on the use of 5 C's. The first C is data collection, correct data collection. The second C is correct equation. The third C is correct substitution. The fourth C is correct evaluation. And then the fifth C is correct answer with SI unit, if any. Meaning there are some calculations that don't have answers. That don't have SI units, while some have SI units. Those that don't have SI units, we call them dimensionless quantities. So please, follow me and see the pattern with which I will attack this question. Right now, we are doing what I call data collection. So let's begin. This is question number calculations in specific yeah, I'm correct. Specific heat capacity. Calculation in specific heat capacity and latent heat. Yes. Calculations in specific heat capacity and latent heat. That is what we are going to look at in this video. So, question number 48. Page 221. The power in the circuit is given as 90 watts. And the time taken for the current to flow to the circuit is given as 5 minutes. Sorry, it is raining heavily down here right now at this moment. So ignore the sound you are hearing. We can't compete with nature. So let's run on. The energy supplied, the mass of the metal is given to be 180 grams. And then, neglecting energy losses to the surrounding, they are asking us to calculate the latent heat of fusion, the specific latent heat of fusion. Specific latent heat of fusion. That is the quantity of heat energy that is required to melt that substance. So, the information is complete. So let's start. You must convert your time to minutes, I mean to seconds. So this is 5 times 60. 5 times 60 will give you 300. This is 300 seconds. You have to convert gram to kilogram. So this is the same thing as gram divided by 1000. That will give you 180 divided by 1000. We're going to have 0.18 kilogram. So we are good. Now recall that the quantity of heat energy supplied into a system using the electrical method is given as mass, is given as IVT. It's given as IVT. And if you recall very well, in the other video I told you that power P is given as IV. And in this case, your power is what? 90 watts. That is your power. And I also told you something. The physics of hot and cold. Recall that the quantity of heat energy required to melt that guy is given as mass of that guy times specific latent heat of fusion. So we can call this equation number 1. We can call this equation number 2. So we are free to equate this guy with this guy. And so we write that this implies that mass LF is equal to what? IVT. So we are going to make this guy the subject of the formula. And if we do that, we're going to have LF is equal to IVT divided by what? Mass. So this is the equation we are going to use to find the answer. So if you do that, this implies that the specific latent heat of fusion is given as IV, that is the power, that is 90 times time times 300 divided by 0.18. If you do that, you're going to have 90 times 300. Our answer here is 27000 divided by 0.18. So that answer divided by 0.18, you're going to have 150,000. So the specific latent heat of fusion is given as that. And what is the answer? The answer is joule per kilogram. That is what we have. Yes. Even in the textbook, that is what we have. The textbook will have 1,000 or 150,000 joule per kilogram. The answer in joule per gram is The answer in joule per gram is 150. Is 150 joule per gram. So it is this 150,000 joule per kilogram or 150 joule per gram. That is that for that. So let's solve the next question, question 49. Question number 49. I hope this is well understood. I left this diagram here deliberately because we'll be using this diagram very soon. So let's clean this and solve another question. So this is that for that. Question number 49. I read. A 10 ohm coil takes 21 seconds to melt 10 grams of ice at 0 degrees Celsius, full stop. Assuming no heat losses, determine the current in the coil, full stop. Take specific latent heat of fusion of ice to be 336 joule per gram. Joule per gram. So let's collect our data. This is question number 49. Question number 49. Calculations in physics, page 221. So data collection, our R is given us 10 ohm. And our time taken, resistance, I'm correct. R is that. The time taken for the current to flow through the circuit is 21 seconds. The mass of ice is given as 10 grams. And the initial temperature, I call it theta cold, of the ice is given as 0 degrees Celsius. Assuming no heat losses, they are asking us to determine the specific latent heat of fusion of the ice. So specific latent heat of fusion of ice is not given. How do we go about it? Very, very simple. Stay with me. So let's begin. We are going to convert everything to the standard units. So this is 10 divided by 1000. You're going to have 10 divided by 1000, you have 0.01 kilogram. Times in seconds, that is cool. So we are good to go now. We are good to go. So the next thing is to write down the correct equation we are going to use. So recall that your H is equals to IVT, right? Your H is equals to IVT. And then the quantity of heat energy that is required to melt the ice from solid to liquid state is given as mass of the ice and specific latent heat of fusion of ice. You can call this equation number 1 and call this equation number 2. Now, the current is not given. They ask us to calculate what? Determine the current. So, the current I is not given. So what do we do? It's not given, and also V is not given. Now recall from Ohm's law. We have that V is equal to what? IR. Right? V is equal to IR. There's no way we are going to look for two unknowns at the same time. So we are going to eliminate V in this equation and substitute this guy in the place of V. So you can call this equation number 3. So substitute equation 3 in equation number 1. So this implies that your H is equals to I times R times T. If you do that, you have H equals to what? I square RT. So your H is equal to I square RT. Call this equation number 4. So we are free to equate equation 4 with equation 2. So we are going to equate equation 4 with equation 2. So we write, so this implies that ML that is equals to I square RT. So we are going to make yes, the specific latent heat of fusion of ice is given in that question as Joe is given that question as 336 joule per gram. Joule per gram. So sorry, this was given. This is 336 joule per gram. And then the current I was not given. So since it was given like this, I will advise we calculate using it the way it is here, using gram the way it is here. So now let's make I the subject of the formula. If we do that, it implies that I square is equals to MLFI divided by RT. So our I is equals to the root of the mass times this divided by R times T. So this implies that our I is equals to the root of the mass is what? We have 10 times 336 divided by 10 times what? 21. So this will go. Your I is given as what? The root of 336 divided by 21. So if you do that, what do you have? You have 336 divided by 21. So we have root 16. Root 16 I believe will give you 4. Root 16 will give you 4. So therefore, I is equal to root 16. Root 16 is 4. Let me verify. Root 16. Yes, I was correct. So therefore, so this implies that that's going to be so. Therefore, your I is equal to what? 4 amps. Lovely. That is the answer. So we are going to look at question number 50. So look at it the way it is. That is exactly how you are supposed to solve it. The reason why I did not use 0.01 kg here is because the specific latent heat of fusion of ice was given in joule per gram. And if it was given in joule per kilogram, I would have used 0.01 kilogram here in place of the 10 kilogram. I believe that is well understood. So let us quickly look at question number 50. Question number 50 reads, okay, let me clean this quickly. Okay. Question number 50, page 221, this book. Okay, let's move on. Heat is applied to a test tube containing 100 grams of ice at its melting point. The ice melts completely in 1 minute. What is the power rating of the source of heat? Latent heat of fusion of ice is 336 joule per gram. We are revolving around the same mountain using different direction. It is the same question we have solved before. So let me quickly solve it and then we'll move to another part of the question. So let's solve. Data collection. This is question number 50. Question number 50. Heat is supplied to a test tube containing mass of ice is given as 100 grams. And then at melting point. At melting point, we simply mean theta cold is given as what? 0 degrees. Theta cold is 0 degrees. Is 0 degrees. And then the ice melt completely. Time taken for the ice to melt completely is 1 minute. It's 1 minute. So what is the power rating of the heat source? Power is not given. And you know that power is equal to what? IV is not given. Power is not given. So what do we do? So we are given the specific latent heat of ice. Specific latent heat of ice to be 336 joule per gram. The next thing to do is to, we are done with the data collection. The next thing to do is to substitute in to bring in the correct equation to be used here. We are still revolving around the same mountain, so we write that our H is equals to what? IVT. And that your H is also equal to what? MLFI. Where LFI is the specific latent heat of fusion of ice. So we are going to equate this with this. IV is what we are looking for. So we are free to say that this implies that your H is equal to what? Power times time. Where IV is your power. Do you get? So this implies that PT is equal to what? MLFI. That is it. So right now we are going to substitute. This is the equation we are going to use. So now we are going to divide both sides by T. So the power in the circuit generated in the circuit is given as MLF divided by time. If you do that, what do you have? We have our power to be given as the mass times specific latent heat of fusion of ice divided by the time taken for that to take place. In this case, we are going to use 60 seconds. So 1 times 60 will give us what? 60 seconds. So our power P is given as what? Mass. Mass is 100 grams times 336 divided by what? 60 seconds. So if we do that, we'll have 100 times 336. That will give us 33600 divided by 60. So that results 33600 divided by 60 will give us 560 watts. So therefore, the power generated in the circuit P is 56 watts. 56 watts. If I am correct, that is what we are supposed to have. Yes, the power is given as 56 watts. To this, we have come to the end of this particular video. I will continue to make more videos on the calculations in this topic, and that will be our video number 5. Subscribe to my channel. God bless you. Bye bye.